Today we're going to look at solving systems of equations again like we've been, except that we're going to push our understanding beyond just solving by a graph. So I want to start by taking a look at an application problem here. We've got Angelo running 7 miles per week, and each week increases his distance by a mile. And Marco runs 4 miles per week, and each week increases his distance by 2 miles. So if we want to write this as a system of equations, we can start with one equation that represents Angelo's total distance. And so we can see here that Angelo's total distance starts out with 7 miles and then is going to increase by 1 mile every week. So after 3 weeks, he's going to be running 10 miles. And after 5 weeks, he's going to be running 12 miles. Then we've got Marco, or Mark here, who started with 4 miles each week, and then every week will increase by 2 miles. So after 1 week, he's going to be up to 6 miles, and after 2 weeks, he's going to be up to 8 miles. And so because both of these are in slope-intercept form, it's going to be real easy for us to graph these two equations just by starting with the y-intercept and using the slope to increase. And so you can see that I have the one equation here representing Mark's distance at any given week. Notice right here, this would be Mark at 5 weeks is running 14 miles. And here we've got Angelo at 5 weeks is running 12 miles. So what we're looking for here is what number of weeks it takes for them to run the same distance. And on the graph that's shown with our intersection point. And we can see here that that's 3 weeks. They would both be running 10 miles. Now we can know that this is the correct answer by going back and checking it in these equations. If we put 3 in for the number of weeks, we have 7 plus 3 is 10. And if we put 3 in for the number of weeks here, we've got 4 plus 6, which is also 10. This problem's easy enough to solve with the graph, but if we wanted to solve it without a graph, we could use a system that's called substitution. And substitution simply says, since this says y equals, and this equation has a y that's supposed to mean the same thing, I can replace the y in the second equation with this quantity here that y is equal to. So my second equation I'm going to write as 7 plus 1x equals 4 plus 2x. Rather than writing y equals, I'm replacing it with what y equals. Now I have an equation with only one variable, and I can solve for x. If I subtract 1x from each side, that's going to get me 7 equals 4 plus x. When I subtract 4 from each side, I have identified then the value of x, which is 3, and then I can come back to one of the original problems and figure out what y is by replacing the x with what I just found and see that y has to be 10. Notice I got the same answer, but I'm doing it without making a graph. There are times where we find that the graphing method is not the most efficient method to solve our problems. So for example, in this problem right here, we've got the band selling carnations for $2 each, and they're buying these carnations for 50 cents each, but they paid a $16 delivery charge. So if we look at their total sales or money that they bring in, the money that they take in is $2 times the number of carnations that they sold. Whereas the money that they're paying out starts with the $16 and then adds 50 cents for every carnation that they purchased. So if I go to graph these two lines, again, they're in slope-intercept form. So if I'm graphing these two lines, I can start by plotting the y-intercept here for my cost at 16, and then going up 1 and over 2, or in other words, increasing a half each time I add a carnation. Now, notice I did label these two axes the same, so I can just go up 1 space and over 2 spaces, even though what I'm saying is when I increase 1 carnation, I go up by 50 cents. If I increase 2 carnations, I go up by $1, 3 carnations, 4 carnations, and so on. I could find a bunch of different points that are on this graph if I wanted to, and that would help me plot that graph as well. The other one, just y equals 2x, I'm starting at 0. And I'm going up 2 every time I go over 1. And again, I could go up 2 lines and over 1 line because they're counted the same way. Now notice our intersection point here is kind of floating in a space. It looks like the height might be around 21, and it looks like the x might be around 11. So I might want to check that and see. If I put into my first equation 11, I'll get 21 equals 2 times 11, but 2 times 11 is 22. So that's not going to work. It's close. Notice if I go back to 10, I'm going to get 20 and not 21. If I go and check in this other one, because maybe it's 11.22, I come check in this one, when I put in 11, 50 cents times 11 is actually going to be $5.50 plus the $16. And so I end up with a cost of $21.50 for 11 carnations, whereas my revenue for 11 carnations was $22. So they're about 50 cents off. If I drop back down to only 10 carnations, then I've got here sales or revenue of $20, 2 times 10, and down here when I use 10, I'm getting $5 plus 16, which is $21. If I try going up to 12, I can check that too, and I'm finding that I'm having a really hard time getting that exact value from my graph because it might not come out to a whole number of carnations. The break-even point might not be a number that I can sell, but rather between two numbers. So if I want to solve this algebraically, I can get the exact value of the solution. And we're going to use the same idea we did on the last one. Since we have a y equals here, I can take that and replace it for the y in the other equation. So instead of saying y equals 16 plus 0.5x, I'm going to say 2x equals 16 plus 0.5x, replacing the y with what y equals. And now again, I can solve this. I'm going to subtract 0.5x from both sides to try to get the x's all together on one side. So now it says 1.5x equals 16. And then if I divide by 1.5, I'm going to get my value for x. Now, I know that 10 sets of 1.5 will get me to 15. Another 1.5 is going to get me to 1650. So I'm going to actually have 10 point something, and I'm going to pull out my calculator to figure out exactly what that is. And when I type that in, I'm getting 10.6 repeating, or 10 and 2/3. And remember, x is the number of carnations. So in order to have exact same cost and revenue, I would have to sell 10 and 2/3 carnations. Obviously, I can't do that. That's why we were seeing something right around 11, because that's the closest number of carnations to getting me that same cost. If I go back and plug this in, I can figure out what my cost is for 10 and 2/3. But at this point, I'm not really that concerned about it because we were just trying to figure this out. I would want to sell 11 carnations for my money that's coming in to be more than my money that's going out. So the large idea here, the big idea behind solving systems by substitution, which is what we were doing, we were substituting, we have to start with one of our equations to have either x or y isolated. I either have to know what x equals in terms of an expression, or I have to know what y equals, because then I'm going to replace into the other equation that value that I just found. I'm going to put that expression into the other equation, and I need to make sure that I'm using parentheses. Once I've replaced that, I have an equation with only one variable in it. So I can solve to find that part. Then I can, once I've found that, I can plug it back into either one of my original equations to get the other half of the point. So we're going to go through and do these steps. And you'll notice I've got the steps kind of summarized right here. So the first thing I need to do is have one of my equations solved for either x or y. In this setup, it says x equals. So I know that this expression is the same as x. So if I come down to my other equation, I can replace the x with that expression because that's what x equals. So if I go ahead and start doing this, it's going to say, and I'm using parentheses, 2y minus 4, that replaced the x, plus 8y equals 16. So I did step 1. I solved for one variable if necessary. It was done. I've done step 2. I've substituted this expression into the other equation. So I'm on step 3 now. I'm solving this new equation to get the value of y in this case. And so when I solve, I'm going to distribute. There's nothing here to distribute. It's just a 1. So I have 2y minus 4 plus 8y equals 16. And so that gets me 10y minus 4 equals 16 when I combine my like terms. And now to isolate the value of y, I'm going to get 10y equals 20. And finally, I can divide by 10 to get that y equals 2. Once I know that value, I've completed step 3. Now it says substitute that value back into one of these original equations. So I can either put the 2 in for y here, and it'll say x equals 2 times 2 minus 4, or in other words, 4 minus 4, which is 0. Or I could have put my value for y into this equation. So it would say x plus 8 times 2 equals 16. This one's going to require a little bit more work, but I can still find the value of x this way. I would subtract 16 and I would still get that x equals 0. So now it says write those values as an ordered pair, x, y. So I've got 0, 2, and then check. I need to make sure it makes both of these equations true. So the first equation, 0, has to equal 2 times 2 minus 4, and that works. And in the second equation, it should say 0 plus 8 times 2 equals 16, and that also works. So that's that verification that our answer is right. This is the solution to that system because it makes both equations true. Notice when I come to my second problem here, I'm going to go through that same process, but the first step hasn't been done for me yet. In this equation, it said x equals. I don't have an x equals or a y equals here. Both x and y are on the same side of this equation in both of these equations. So either one of these I'm going to have to solve for either x or y. Now, you can solve for whichever one of the 4 you want to, but I would not recommend solving for any variable that's going to require division unless everything in that equation is divisible by the coefficient. If I want this equation to say x equals, I would subtract y, and then I'd have to divide everything by 2. Since I only have one y, that's going to get me a half y. So I'm going to avoid doing that whenever possible. Any of the other variables that I choose to solve for will lead to just adding or subtracting. I'm not going to have to divide. So just for fun, let's solve for x in this equation again. I could have solved for y, but I'm going to solve for x. And I'm going to get that x equals negative 7 minus y. Now, because this is what x equals, I can go to the other equation and I can replace the x with this. Now notice in this problem, and this is why I chose to solve this way, in this problem it says I have 2 times x. So if I'm replacing x with this quantity, I have to have 2 times that entire quantity. And that's why it's important when I replace a variable to use parentheses. So I have 2 times that quantity plus y equals negative 4. Again, you have an equation with only one variable. If we go through and solve this now, I'm going to distribute the 2 first and get negative 14 minus 2y plus y equals negative 4. And combining like terms over here gets me a negative 14 minus y equals negative 4. So if I add 14 to both sides, I can get that negative y equals 10. So that means that dividing by negative 1, y has to be negative 10. So once I've got one value, I want to go back and find the other part, yet I still need x because I'm looking for a point. The easiest place to go is the equation that says x equals. So if I put my value for y up here, it says x equals negative 7 minus whatever y is. Now y is negative 10. Again, I'm replacing with parentheses. Notice the double negative. I was subtracting y, and y is negative. So this becomes plus a positive. And I end up with x equals 3. Don't forget the final step. I'm going to write my answer as a point, xy, 3, negative 10, and I need to check it back in the original problem. So 3 plus negative 10 is negative 7. It worked there. 2 times 3, that's 6, plus negative 10 is negative 4. So it also worked there. That's your solution. I want you to try this problem on your own. Look carefully at this. Think very carefully about which letter you should be solving for. If you want to get it to say y equals, you're going to divide everything here by 4. If you want to get it to say x equals, you're going to divide everything by negative 5. Down here, if I want it to say y equals, I'm going to divide everything by negative 4. This is the only variable that doesn't require division. So the best choice out of all of these would be to get this one to say x equals. So I want you to go ahead and do that. Solve for that equation to get it to say x equals. Substitute that in for x in the other equation. Solve and go through that process. Don't forget to check. Pause the video right now and then go through that process. Okay, I've got a couple steps here shown. I'll walk you through what I've done so far. In this equation, we decided we were going to solve for x. So to get x alone, I needed to add 4y to both sides, which left me with x equals 4y plus 11. So I'm going to go to the other equation, and since this is what x equals, I'm replacing x. And so I've written that down here, the equation 4y minus 5 times, and then I had parentheses, and I left a gap there initially, equals 9. So I wrote the equation leaving a gap where I was going to substitute, and then I wrote that expression in. This way I don't lose track of where I am. Now I need to solve this. So the first thing I'm going to do is simplify this side of the equation by distributing, and it's a negative 5 that's being distributed. Remember this change to add the opposite. So I'm going to end up with a negative 20y and a negative 55. When I combine my like terms, I get negative 16y minus 55 equals 9. So now I'm going to add 55 to both sides to try to get this by itself. And I end up with negative 16y equals 64. And dividing by negative 16 on each side gets me that y is equal to negative 4. So once I figure out what y is equal to, now I'm going to plug this back into any one of these equations. As long as it's got an x and a y, I can plug it into it. I like to use the one that says x equals because I'm trying to find x. So I'm going to replace the y with negative 4. And I'm going to go through and do the multiplications and the additions and get that x has to be negative 5. Now, remember the last step is very critical. I'm writing it as a point, x, y. This is where those two lines would intersect, and I'm checking it. So in my first equation, notice how I'm putting these gaps. This way I don't have to try and think about two things at once. X minus 4y equals 11. So in my first equation, it says 4 times y. There's my y, minus 5 times x, here's my x. And so I get negative 16 minus negative 25, double negative. And when I add these up, I do get 9, so it works there. My other equation, it says x, that's my negative 5, minus 4 times y, that's my negative 4. And so I get negative 5 minus negative 16, that's plus a positive, and that does equal 11. So that's the proof that we've got the right solution, and therefore we know that we're going to get it right. Always make sure you check your answers. That is the way you know for sure that you will have gotten it right. If it doesn't work, go back and look through your work. Maybe it was something as simple as forgetting to distribute a negative.